So what it tells you is that you can keep track of time even though you have no freaking idea what's going on.
But what exactly is it that we're measuring?
Time is defined to make motion look simple.
That time doesn't exist at the most fundamental level.
If someone came up to you on the street and asked you to draw time, what would you draw?
I was stuck in time. We can't move forward or backwards in time arbitrarily.
Imagine a world where time flows differently for everyone, where you could travel to the future or the past with just a few steps, where the past, present, and future exist simultaneously. This may sound like science fiction, but it is actually a reflection of the latest scientific understanding of time. Time is one of the most fundamental and mysterious concepts in the universe. It is something that we all experience, but we don't fully understand what it is or how it works. In this video, we will explore the nature of time as understood in classical, quantum, and relativistic physics. We will also dispel common misconceptions about time and space. Before we begin, make sure to subscribe to never miss any updates. Also, check our playlist, which contains all the major recent scientific discoveries. Let us begin with classical physics. Here, time is seen as a linear, universal dimension. It flows at a constant rate for all observers, regardless of their motion or location. This view of time is based on the everyday experience of time passing, and it is consistent with the observations of classical mechanics. For example, if you drop a ball, it will always fall to the ground at the same rate, regardless of whether you, the observer, are standing still or moving. This is because the laws of physics and classical mechanics are the same for all observers in uniform motion. Another example is the pendulum. A pendulum will always swing at the same rate, regardless of where it is in the universe. This is because the pendulum is governed by the laws of gravity and inertia, which are universal laws of classical physics. This classical view of time is also consistent with the experience of our everyday lives. We all experience time passing at the same rate, and we can all agree on the order in which events occur. However, the classical view of time is not complete. It does not explain how time works at the quantum level, and it does not account for the effects of gravity on time. So let's zoom in. In quantum physics, time is seen as a quantum operator that is intertwined with space. This means that time and space are not separate entities, but rather two aspects of the same four-dimensional space-time continuum. It also suggests that time is not linear, but rather relative. This means that the passage of time can be experienced differently by different observers, depending on their motion and gravitational field. One example of a quantum phenomenon that demonstrates the relative nature of time is quantum entanglement. In this, two particles are linked together in such a way that they share the same fate, even if they are separated by a large distance. There is a detailed video on the same, linked in the description below. Now, if you measure the momentum of one entangled particle, you will instantly know the momentum of the other particle, even if it is on the other side of the universe. This suggests that the two particles are connected in some way that transcends space and time. Another example is quantum tunneling. It is a phenomenon in which a particle can pass through a barrier that it would not normally be able to pass over. For example, an electron can quantum tunnel through a thin barrier, even though it does not have enough energy to overcome the barrier classically. This suggests that the electron can take a shortcut through space and time to get to the other side of the barrier. The quantum view of time is a complex and fascinating one. It challenges our classical understanding of time as a linear and universal dimension. Quantum physics suggests that time is more fluid and dynamic than we previously thought. Let's zoom off to relativistic physics. Einstein's theory of special relativity revolutionized our understanding of time and space. According to special relativity, time and space are not absolute, but rather relative to the observer. This means that the passage of time can be slowed down or even stopped by moving at very high speeds. Special relativity also suggests that the past, present, and future are not fixed, but rather exist simultaneously for all observers. This means that time travel is theoretically possible, although it is not clear whether it is physically possible. This gives me an idea. I shall share it in the next video. One of the most famous predictions of special relativity is the time dilation effect. This is a phenomenon in which time slows down for objects that are moving at very high speeds. This effect has been experimentally verified using atomic clocks, and it is used in GPS satellites to correct for the time difference between the satellites and the ground. We have a detailed video planned for them as well. The relativistic view of time has had a profound impact on our understanding of the universe. It has shown us that time and space are not fixed entities, but rather dynamic and interconnected. It has also opened up the possibility of time travel and other exotic phenomena. As these theories give various interpretations of time, misconceptions are bound to happen. One common misconception about time is that it is an arrow that flows in one direction from the past to the future. However, quantum physics suggests that time may not be linear at all. It is possible that the past, present, and future exist simultaneously, and that we are simply moving through time in one direction. Another common misconception is that time is universal. However, special relativity suggests that time is relative to the observer. This means that the passage of time can be experienced differently by different observers, depending on their motion and gravitational field. It is important to correct these misconceptions about time because they can lead to misunderstandings about the universe and how it works. For example, if you believe that time is universal, you might not be able to understand why time dilation occurs in special relativity. Additionally, misconceptions about time can lead to false beliefs about the future and can have a very detrimental effect on our outlook. For example, if you believe the future is fixed, you might be less likely to take action to improve your life. I will ask you a question that has been pondered by philosophers and scientists for centuries. If time is relative, and the past, present, and future may exist simultaneously, could it be possible to travel to different points? And if so, what would that mean for our understanding of free will and causality? There is no easy answer, but it is a question that fascinates us